In this video, we are going to do the first arbitrage in our smart contract from Kyber to Uniswap. So we are going to buy Ether on Kyber and sell it on Uniswap. So in our smart contract, we go to the call function, and if arbinfo.direction equal the direction of Kyber to Uniswap, then we buy ETH on Kyber, sell ETH on Uniswap. So the first thing we need to do is to approve the DAI to be spent by Uniswap. So for that, we use the approve method. We give the address of Uniswap, and for the amount, that's a whole balance of DAI. And after, we're gonna call Kyber get expected rate, and this is gonna have 3 arguments. First, a pointer to the token that we provide in input, so that's DAI. Then a pointer to the output token, so that's Ether. And here we need to put the constant that we created before Kyber ETH address. So this is a thing that is just used by Kyber. It doesn't mean anything for the other smart contract. Of course, Ether doesn't have a token. This is just how Kyber reference Ether. And after, the amount of DAI that we want to trade, and this is going to return a tuple. So we're gonna have several values, but we just want one. That's the expected rate. So the way we ignore the other parameter is like this. And after, we can finally trade. So for that, we're gonna use the method swap token to Ether. So the input token is DAI, the balance is balance DAI, and the rate is expected rate. All right, so with this, we buy Ether on Kyber. So now we're gonna sell our Ether on Uniswap. So to trade on Uniswap, it's slightly more complex, because if you want, you can do a series of operations. So you can go from token A to token B to token C. So instead of just specifying an input and output token, you're going to specify a path, even if you actually just want to involve 2 assets like we're going to do. So we're going to define this path. So that's going to be an array of address in memory. We call this path. That's how you declare a memory array in solidity of length 2. And after, we're going to assign a value for the first and second element. So the first element is the address of wrapped token. So on Uniswap, you don't deal with Ether, but you deal with wrapped Ether. And for pass 1, so the second element of the array, this is the address of DAI. And after, to get the price of DAI, we're going to execute get amount out. So in input, we're going to provide the balance of this smart contract, and we remove 2 because we're going to need to pay the DYDX protocol for the flash loan. And for the path, then we put the array, and this is going to return an array of integer. So why an array of integer? Well, because in our path, if we have more than two elements here, so if we have 3, we'll have 2 different amounts, one for the from pass 0 to pass 1, and the other one from pass 1 to pass 2. In our case, we're just going to have an array with a single value. So here, memory, we declare a value called min out, and now we can finally call the function of Uniswap to actually do the trade. So that's going to be swap exact ETH for tokens. And here, this is going to be the syntax to send some Ether to Uniswap. So dot value address this dot balance -2 to pay for the spot contract of Uniswap, and after another set of parentheses to specify the argument of this function. So it's not very readable, but that means call this function with this argument that we're going to specify here, and also send this amount of ether to the contract. After, so we specify the minimum price that we want, so that's the first element of this array, then the path, then the address of this contract, so that's for who is going to receive the tokens, and the deadline, so the deadline is now. So this is useful only if you send a transaction from outside the blockchain. There can be a big time difference between the time when you send a transaction and when it's finally executed. And if the market moved a lot, then probably that the price that you specify is not a good one anymore. So with this deadline parameter, you can protect yourself. But in our case, we know that this is going to be executed right away because we call from inside the spot contract, inside the blockchain. So I realized that there are a couple of bugs in the contract, so we're going to fix them. So first we scroll up, and here this requires statement should be after the if. So after the arbitrage, we're supposed to have enough money to repay the loan of DYDX, but not before, because repay amount is basically what we borrow plus two-way. So of course, at the beginning, before the arbitrage, we haven't made any profits, so we don't have these two ways. Then let's scroll up, and here we need to approve Kyber and not Uniswap. And after, when we get the prices from Uniswap, so we don't need to remove two-way here because we are in the middle of the arbitrage, but the fee of DYDX is repaid at the end of the arbitrage, so we don't need to take this into consideration at this stage. And also here in min-out array, we want not the first entry, but the second entry. And finally, we need to scroll down, and we're going to create a new function in order to receive ether from Kyber. So when you just send ether to a spot contract, but you don't call any function, that means you're going to execute the fallback function. And if this fallback function does not exist, the transfer of ether is going to fail. So we need to create this fallback function. So that's a function without any name. We make it external so that it can be called from outside. We make it payable so that it can receive ether. And the body is empty. We just need the function definition here. And this is all we need to do the first arbitrage from Kyber to Uniswap. So we're going to stop here, and in the next video, we're going to do the other arbitrage from Uniswap to Kyber.